Hi students, today we are going to see about gas turbine cycle problem. In this problem, we are given P1, P2, T1, T3 and efficiency of turbine and efficiency of compressor. Where P1 is the inlet temperature of the compressor. We know the gas turbine cycle. This is a compressor, combustion chamber, and this is a turbine, gas turbine. If it is a closed cycle, it is a pre-cooler. Open cycle means this pre-cooler will not come. So 1 to 2 is compression, 2 to 3 is a combustion, 3 to 4 is expansion in the turbine. So here P1 is inlet temperature of the compressor. P2 is the outlet temperature of the compressor. T1 is inlet temperature of air which is entering the compressor. T3 is inlet temperature of the gas which is entering the turbine. And eta T is efficiency of the turbine and eta C is efficiency of compressor. In this problem, we are asked to calculate the efficiency of the cycle. There are two cases. The first case, there is no regeneration, and second case, regeneration is considered. Let us see a cycle without regeneration. Okay, so here we are going to draw the PV diagram. 1 to 2 is compression, 2 to 3 is combustion, 3 to 4 is expansion. And in the TS diagram, 1 to 2, which is shown the hidden line, is isentropic process, and 1 to 2 dash shown by a thick line is the actual process. Similarly here 3 to 4 shown by a hidden line in a vertical manner is isentropic but ideal process, and 3 to 4 dash is the actual process. Now our motto is to find the efficiency of the cycle. We know what is efficiency: output by input. Here output is net work output of the cycle, and input is heat supplied. The net work output is nothing but work done by the turbine minus work input required to run the compressor. The work done by the turbine is nothing but Cp into T3 minus T4 dash. In the TS diagram, this is the turbine, and we are going to consider the actual cycle. So T3 minus T4 dash is nothing but work done by the turbine. That is what we have taken here, T3 minus T4 dash, and the compressor here T2 dash minus T1. So Cp into T2 dash minus T1, because we are going to find the work done by the turbine and work input required to run the compressor, or in terms of enthalpies, we know H is equal to Cp into T. Therefore, H3 minus H4 dash is nothing but Cp into T3 minus T4 dash, and H2 dash minus H1 is nothing but Cp into T2 dash minus T1. In this equation, T3 and T1 are given in the problem itself. T3 and T1 are given in the problem itself. We want to find T4 dash and T2 dash. So T2 dash is coming in compressor and T4 dash is involving in turbine. So by using the compressor efficiency, we are going to find T2 dash. By using the turbine efficiency given in the problem, we are going to find the T4 dash. Let us see how to find T2 dash. So by using the compressor efficiency, what is compressor efficiency? Ideal work input divided by actual work input. In the compressor, this is the actual work input and the ideal work input. Since the actual work input is more than ideal work input, the efficiency is ideal by actual. So T2 minus T1 divided by T2 dash minus T1 is nothing but compressor efficiency. In this T1 and T2 are given in the T1 is given in the problem. If we know T2, we can find T2 dash. How to find T2? T2 is involving in isentropic process. Therefore, we know the relation T2 by T1. T2 by T1 is equal to P2 by P1 power gamma minus 1 by gamma. In this problem, both P1 and P2 are given. So we can find out the T2 as T1 into P2 by P1 power gamma minus 1 by gamma. So T2 we got as 477.3 Kelvin. By substituting the value of T2, T1 and efficiency of compressor, we can find out T2 dash. Once we know T2 dash, we have to find out T4 dash. How to find a T4 dash? By using the turbine efficiency, we are going to find T4 dash. What is turbine efficiency? Actual work output divided by ideal work output. Because in the turbine, actual work output is going to be lesser than the ideal, because the friction is considered in the actual practice. So this is actual and this is ideal. So T3 minus T4 dash divided by T3 minus T4 is nothing but a turbine efficiency. In this problem, T3 value is given and efficiency of turbine is given. If you know T4, we can find T4 dash. How to find out T4? We know 3 to 4 is isentropic process. Therefore, T4 by T3 is equal to P4 by P3 power gamma minus 1 by gamma. T3 by T4 is equal to P3 by P4 power gamma minus 1 by gamma. We know P2 is equal to P3 and P4 is equal to P1, where P2 by P1 is equal to P3 by P2 is equal to RP, pressure ratio. So therefore, we can find T4 is equal to T3 by Rp power gamma minus 1 by gamma. We know the gamma value of air is 1.4 forever, and T3 value given in the problem, and pressure ratio we know it is 5.2. So from this we can find out T4 by substituting the value of T4, T3 and eta T. We can find out T4 dash. Once we know T4 dash and T2 dash, we can substitute here and we can find out net work output. And what is heat supplied? Heat supplied takes place between 3 and 2 dash. So it's nothing but H3 minus H2 dash in terms of temperature Cp into T3 minus T2 dash. So T2 dash is known, T3 is given, so we can find out the heat supplied as 323.16 kilojoules per kilogram and net work output as 62.31 kilojoules per kilogram. Now the efficiency is net work output by heat supplied. By substituting the corresponding values, we can find the efficiency whose value we got as 19.28%. This is without regeneration. When we consider a regenerator with the effectiveness of the regenerator as 66%, let us see how to find out the efficiency. As usual, efficiency is net work output divided by heat supplied. The heat supplied in this case is going to be T4 minus T3 dash. T4 minus T3 dash. So T4 is already found. T4 already we found. T3 dash we are going to find by using the formula, effectiveness formula. So what is effectiveness? T3 dash minus T2 dash divided by T5 dash minus T2 dash. So T3 dash minus T2 dash divided by T5 dash minus T2 dash. In this TS diagram, both T3 dash and T5 dash are lying on the same horizontal line, but in actual practice, both may not lie on the same line because T3 dash may not be equal to T5 dash. If T3 dash is equal to T5 dash, then effectiveness will be 100%. This is not at all possible in actual practice. So since they both are different, we get a lesser value as 66%. So with the aid of T2 dash, T3 dash and with the aid of T2 dash, T5 dash and epsilon, we can find out T3 dash. By substituting this value, we can find out heat supplied. But though we use a regenerator, there is no change in network output. Whether regenerator is considered or not, network output will not change, only the heat supplied changes. Now, when we consider regenerator, the efficiency of the cycle is 21.3. So, from this it is clearly understood that the regenerator is improving the efficiency of the cycle. Thank you.